All right, so this one, we are given our information in a table. It says the height of a tree at time t is given by a twice differentiable function. That means it's also continuous. That's probably going to come up at some point. Height is measured in meters, time is measured in years. A lot of the problems, they give you a rate. This one, they did not give you a rate. This is just the height of the tree in meters. That's just actually how tall it is at that time. So it's not a rate. All right, so let's see, for letter A, use the data in the table to estimate h prime of 6. Derivative means slope, so all they're asking us for here is a slope at 6. Now 6 isn't on the table, so we're going to use the points around it. So we're going to use the point 5, 6, and 7, 11. And then just do that slope. So it would be 11 minus 6 over 7 minus 5. You don't have to simplify that down, so don't. And then we have to, interpret that with correct units. Actually, so I just said I wasn't going to simplify it down, but since I have to write a sentence with it, I actually will. So this will be 5 halves. So what that is a slope. It's a rate of change. It's an estimate for the derivative. So our units are going to be meters per year. And so the tree grows at a rate of 5 halves meter per year at time 6 years. So that is our explanation in the context of the problem. So again, we did an estimate for a derivative. That's a slope, it's a rate. So in the context of the problem, the tree is growing estimate at a rate of 5 halves meters per year at time 6 years. All right, letter B. Explain why, this is going to be one of our theorems here. Explain why there must be at least one time from 2 to 10, so that's the interval they gave us, such that h prime of t equals 2. Here's what I don't like about this problem. This is going to be mean value theorem. So as long as the slope equals 2, then we know the derivative is going to equal 2 at some point. Remember, average rate of change equals instantaneous rate of change. That's our mean value theorem. The thing is, from 2 to 10, if you use these 2 points, it won't give you a slope of 2. You have to figure out which 2 points in here, if you do a slope, is going to give you a slope of 2, which is kind of annoying. You have to try them until you get one that's going to give you a slope of 2. It's going to be the point 3, 2, and 5, 6. So this is actually going to look really similar to what we just did in part A. We're going to need to do the slope for these. So if you do 6 minus 2 over 5 minus 3, that gives you 4 over 2, which is 2, which is what we're looking for. So again, it wasn't from 2 to 10. You have to find an interval somewhere in there where you're going to get a slope of 2. So it's mean value theorem. You have to mention that the function is continuous and differentiable. We're told it's differentiable, so we know it's continuous. So since h of t is differentiable, it is also continuous. So by mean value theorem, and you can abbreviate that, they'll take MVT for that. So by mean value theorem, and then you can pretty much recopy the problem. You just need to show the slope, mention that the function is continuous and differentiable, mention the theorem. So by mean value theorem, there must be at least one time, I'm literally just copying this, at least one time t for, now this says 2 to 10. You can say 2 to 10, or the interval we did was 3 to 5. I can't think it would make a difference. I'm just going to recopy what they put here. So for 2 to 10, such that h prime of t equals 2. So we found these 2 points where the slope was 2. We mentioned the conditions of the theorem. We mentioned the theorem, and then I kind of just recopied the problem. All right, so part C, use a trapezoidal sum with the 4 subintervals indicated by the table to approximate the average height of the tree over the time interval 2 to 10. All right, if you just do a trapezoidal sum, you are going to lose a point because they threw this little word in here, average. If you miss that and don't do an average value, then you will lose a point. So average height, remember average value, if I asked you to average a list of numbers, you would add them all up. So we're going from 2 to 10. The integral is what adds them all up. And then you have to divide by how much you have. So out front, we have to put this 1/10 minus 2. So if you miss that fraction out front, you're going to lose a point. And it's easy to miss because they just like slide it right in their average height. All right, so this is going to be 1/8 out front here. And then we're going to do a trapezoidal sum. It's a lot of writing, but it's not necessarily difficult. It's very formulaic. And if you just keep doing the same formula over and over, you're going to get it. All right, so for a trapezoid, it is 1/2 and then times the height, which is the length of the interval. So the first one from 2 to 3, that's 1, and then add the bases together. All right, and then 1/2, and then the next one from 3 to 5 is 2, and then add the bases together. And then the next one from 5 to 7 is 2, add the bases together, it's 6 plus 11. And then last one, 1/2, 7 to 10 is 3, and then add the bases together. And then this would be meters. All right, so letter D, there's a lot written for this one. The height of the tree in meters can also be modeled by the function g, which is given by that equation that we've got right there. X is the diameter of the base of the tree in meters. When the tree is 50 meters tall, so let me list out the information. When the tree is 50 meters tall, so that's when G is 50. This is going to be a related rate here, just as a heads up, right? So when the tree is 50 meters tall, the diameter of the base of the tree is growing at a rate of 0.3 meters per year. So that's our dx dt. It's growing at 0.03 meters per year. That's our rate. Remember, for related rates, it's all with respect to time. What is the rate of change of the height of the tree? All right, so dg dt is our question mark. What is the rate of change of the height of the tree? It should be positive because the tree is growing. When the tree is 50 meters tall, and it's like you already said that. You already said that g was 50. All right, so we are going to take the derivative of this, everything with respect to time. So it will be dg dt equals, and now this is a quotient rule. So they're testing you on the quotient rule. So let's review that. Quotient rule is the denominator times derivative of the numerator, which would be 100 dx dt, minus the numerator times derivative of the denominator, which would just be dx dt. Derivative of a constant is going to be 0. And then over the denominator squared. All right, so again, quotient rule, denominator, derivative of the numerator, minus numerator, derivative of the denominator over the denominator squared. All right, now we're going to plug in everything that we've got. All right, so x, oh, you know what? We don't have x. We have to go back and find that. All right, so we are told g is 50. We're going to plug in 50 for g. And we have to solve for x. So I'm going to multiply this 1 plus x over. I'll have to distribute the 50 through that. So it'll be 50 plus 50x equals 100x. Again, I just multiplied this 1 plus x over. I just distributed the 50 through it. All right, subtract over the 50x. And we get that x is 1 meter. All right, so we're going to plug in 1 for x. All right, so 1 plus 1 is 2, and then times 100, and then dx dt is 0.03, minus 100 times 1 would just be 100. Then dx dt again is 0.03. And then over 1 plus 1 is 2, squared is 4. You don't have to simplify that down, so just leave it. This is dg dt, so it is a rate, so it is meters per year. And I just realized I didn't put an A in my year there. All right, let me go over the points for this one. All right, so in part A, you get a point for doing this slope, and then you get a point for explaining what it means. In part B, you get a point for doing the slope, and then a point for your explanation. Part C, you get a point for doing the trapezoidal sum, and then a point for making it an average. And then in part D, part D here, you get a point for, let me see, it's 2 points for the derivative, which is fair because that's a lot, and then a point for plugging it all in and getting your final answer.